You know, it's interesting. You mentioned the $100 bills, and I was talking to a friend of mine today that deals mostly in cash. He's kind of an old school guy, and he was talking about how nobody wants cash anymore. First time in the history of the United States that nobody wants $100 greenbacks right now. So I'll take them as long as they're wiped down with a sanitizer wipe. And but we will catch up on all of you as time goes on. One of the things that I wanted to mention also is that we introduced the slate of officers for 2020-2021 board of directors at the last dinner meeting, and it will that board will take over on July 1 for the next fiscal year of our Apics chapter. We are going to wait and see where the summer goes. We'll probably do a vote in the fall whenever we can get together again. But we're going to continue forward with that slate that was approved by the membership at that dinner meeting in March. Evan, do you want to talk to us about membership and continuing membership?
Yeah, sure, I will. Yeah, so hey everybody. Right now, as far as membership, just give a quick snapshot of where we're at. Previous updates would have put us at probably around 350 to 400 members. Recently, latest numbers are showing right around 315. It's kind of no news for a lot of people, unfortunately, may have lost their jobs due to what's going on, which presents actually a good benefit of being an Apics member with an unemployed membership extension program. So just like Department of Labor has unemployment benefits, so does Apics. So I'm going to talk through that briefly. There is more information online on the Apics website. Just type in unemployed membership benefits or contact me directly. I'd be happy to help you through it. But basically, if you're an unemployed member and your membership's coming up for renewal and you're actively seeking work within the supply chain management field, you can basically qualify for an extension. The cost is free. The extension comes basically in 6-month periods, and you can do that 3 times, so basically 18 months of an extension. You just contact really anybody through the chapter, and you fill out a form. Basically, the chapter fills out a couple of things, and we submit it to corporate. So it's pretty much that straightforward. Just when you do get a notice for renewal, either from corporate or from myself, just reach out to one of us and we'll be happy to help you along with it. Other than that, that's it for membership at this time.
Fantastic, thank you, Evan. That is really a great benefit. I know there's a couple people that we've heard from in the last few days, and all it takes is a very simple form, no fuss at all. We'll sign that, we'll get it into corporate. Your membership will be extended for 6 months, and then we can do that 2 more times. So please do that, and Evan's got the form. He can get them right to you. It's very easy. The other thing that I wanted to mention to everybody, as long as we're here, is we'll be talking about it when our next fiscal year starts. But when our fiscal year starts at the beginning of July, we expect to have an announcement of a merger with another chapter. And we will be we will be larger and stronger together. We'll have more members, more geography as part of the Colorado chapter. So I think that that synergy that we've been building the last few months when we've been talking about this is going to come to bear fruit. And as we start the programs in the fall, we will be stronger and bigger. But before I turn this over to Joe to introduce the speaker, I just wanted to again say thank you all for attending. Our schedule, we'll let you know what our schedule for the summer is. It'll be somewhat altered, I think, this summer from our normal shutdowns through the summer. And we'll keep you informed, and we'll be doing things across the web just like this tonight. And I just want to personally tell you all, this is a dangerous, dangerous virus. If you think that it's not, please change your thinking. Stay at home, be as safe as you can, keep your families as safe as you can. and we'll get through this, and together we'll all have hope, and we will get through it. Joe, would you like to introduce our speaker?
Greetings, everyone. How you doing? Did everybody have a great dinner? If you read the newsletter up, I myself had gotten a barbecue brisket burn ends with some green bacon, green beans with bacon in it. Sipping on some great whiskey right now, and I actually did make a chocolate a layered cheesecake for the family. So I'm trying to make the most of the situation. Actually, I'm just kidding. I did not have all those things. I do have the cheesecake, but the rest of it, I've been working pretty hard with the coronavirus with National Guard, and I did not make the burn ends. So I hope everybody did try and have a good meal. Being able to stay at home, you do have an opportunity to do that. On to our programs. It has been my honor to get to know Kevin very well. You have to work very hard to try to make sure we stay current on our topics. And autonomous robots really are the cutting edge, and not many of us get a chance to work with them or get to know them that well at all. And so it's a great honor and an opportunity for us to have Glynn, who's got more than a little bit of experience with it. Kevin is a technology independent consultant nowadays, but he was a CIO for a multinational manufacturer. He's been the VP of operations. He's been the multinational distributor for a third-party logistics company. And he's an early implementer of the autonomous mobile robots, as well as use of drones within a warehouse, which I'm not even sure I'd even read one article yet on how to do drones in a warehouse. So that's just fantastic that we've got this high quality speaker to come talk to us. And I would like to introduce Kevin. Take it away.
Thanks, appreciate it. I'm gonna turn on my camera and I'm gonna share my screen. All right. So good evening, everyone. I hope you guys are actually, staying safe and being mindful of trying to keep other people safe as well, just like Roger said. We're all in this together, and I hope that we can, well, hopefully it gets better fast, because it's a big inconvenience. So we'll talk about mobile robots here. There is a chat up. I'm not looking at the chat right now, so if there's something big that you want to interrupt, flag it on the chat. Maybe Joe or Bill can interrupt me. We will open up at the end for general questions without restriction. So to take it away, we're going to talk about mobile robots and how they work in manufacturing and in warehouses. So we'll talk a little bit about how they work, what the new technology is, some of the vendors in the market that's out there in terms of who you might want to go get a robot for your facility, and then some implementation questions, and finally a Q&A. A little bit about me, just as I said, I'm both a manufacturing guy. I started my career as an industrial engineer in a factory, and went into the technology space. Some people say I went to the dark side and wound up as a CIO of 3 different companies. And I did implement some of the first mobile robots in 2018, late 2018. So I've got about 18 months of firsthand knowledge about how it goes. And then just at the end, my plugs for Apics. I am an Apics. I've got my basic certification from several years ago. So simple definition of robots. These are robots for transporting material. We're not going to talk about some of the other ones. I've got some examples. If you want, we can talk about drones at the end. They're also called AMRs, Advanced Mobile Robots, and they're different from AGVs. And specifically, we're not talking about over-the-road robots. So this is stuff that's going to go in a warehouse, that is going to work in your manufacturing space, maybe go between buildings. You can go between an alley or something, but not necessarily get on a road like a truck. So what's changed in this? Why is this so unique? And the answer is that these AMRs that have come out are the next generation above AGVs. A lot of us have worked with AGVs. They've been around for almost 30 years in one form or another. And the old technology would, you'd have to lay down some sort of wire on the floor or in the ceiling or something like that. And the robots could really only follow that track. They couldn't deviate too much. They might have a little bit of flexibility to go left or right. They also could detect obstacles, but they would pretty much generally stop. Someone would have to go over and push the green button to make them work. So much more restrictive, expensive to set up. That was the big one, that you would take, several weeks to get these things deployed, versus the AMRs now are deployable in a matter of days. And we'll talk a little bit about that. So the new robots, these advanced mobile robots, navigate using software that you have loaded into the robot. So usually you take a CAD drawing of a facility, which has the fixed columns in the, for the roof, fixed machines and so forth, and then it from there learns what are the good paths and where it should be and so forth. It's got safety protocols in terms of when to stop and so on. We'll talk about that. These mobile robots then typically go to locations and they wait for someone to do something to them, put some parts on it, put a pallet on, so on. We'll go through a little bit of that. And they use cameras and LiDAR sensors for safety, and they're all around the vehicles. And that's what's really the game changers. All these sensors are cheap, and the processing power that you can put on the robot to manage the safety questions and the navigation is all inherent in the robot. So most of these people making it are actually not hardware people. They're mostly software folks. So we'll talk a little bit about where these things are coming from. It's a pretty interesting industry that's different than what you'd expect. The last one is AMRs can move around an obstacle. So if they sense something in their path, they can stop, see what's going on, and then they will deviate and find another path, including going down another aisle altogether and so on. And that's what makes them so much more flexible, because that also relieves congestion. If you've got problems in the aisle, problems in the machines down, and maintenance has got all their gear in the aisle, the robot will find its way to another spot, to its destination in another fashion. Okay, so how does it work? And typically there's two technologies. The LiDAR is the dominant one. So it's a light sensing, the sensor puts out a radar signal, a laser signal, and then it bounces back, just like radar, only using light. And these are very cheap. They're tunable, so you can have them aimed in different ways, up, down, sideways. You can have them hypersensitive, close in. You can have another sensor look far out. And you can see this, the same sensors that you're putting on it have a huge range, from a centimeter in front of it to out to 60 meters, which is about as far as you need if you're indoors. And again, these are really relatively cheap to put on, and a typical robot will have somewhere around a dozen of these things on them, mostly looking at a perimeter, and a few will be looking up to the ceiling and so forth for other issues. And then depending on the size of it, if you have big wheels, they might be looking down so it doesn't roll over something. Okay, the interesting thing about this stuff is that because this is industry that's being dominated by startups, they've been unconstrained in terms of what kind of form factors they've built. So here's two examples of what they call deck-mounted robots, and you basically use them to move pallets. So they're about 4 feet square, roughly, and they can take up to, depending on what you want, you can see the one on the left will hold 1,100 pounds. Most of them are being sold are out around the 3,000 pound, and if you could get a really heavy one if you needed one. But typically it'll take an average pallet, and it just trundles along and takes your pallet where you want to go. You do still need generally a forklift to put the pallet on, so someone's got to be at the beginning and the end. Or you have these little kind of bays and so forth where it goes in and then we'll kind of leave it there. A couple other applications will show that work in harmony with these and how they work. So the next generation of other type of robots are picking robots. So these are moving boxes and totes and things like that. So think of in a warehouse application, if you're building a kit or doing picking for going out to in an outbound distribution center, you've got a operator who's going up and down the shelves. He's following that pad that's on the top of that little on the lower right there. He's following directions on the orders, and he's putting things into those colored bins and using a barcode scanner and so forth. Over on the right, you have an example of Fetch, which is one of the bigger robotic companies. They're startups, and they're moving boxes, and they have all kinds of different form factors. But the idea is that they're moving totes and bins, and you can really understand the application in a manufacturing or warehousing each picking environment where people are just assembling things and then you have to take it somewhere that's relatively far away. These robots, just like the deck-mounted ones on the previous slide, are mature offerings. So you can buy these at scale, and that means you could go order 100 and you would have some hope that they would show up pretty soon, right? Not the case with some of the other ones that I'll talk about. They also have some software and so forth that goes with it, and I'll get to that. You're also seeing an explosion in technology around the arms that grab things. So if you go to an automation show now, you will see an overwhelming amount of arms, articulating arms that can grab, and they use different technologies. There'll be soft fingers that are fluffy foam to grab something. They'll have air suction to pick it up, and they have various strengths. So these two are just picking up little bits and pieces. This would be for an e-commerce warehouse or the backside of a large retail operation. They're also putting these things on wheels. So that one on the left actually is a movable robot. It will move up and down the aisles, just like those robots in the previous slide. And it stops at the right place, and will pick what it needs. These arms are using an extra set of sensors with vision. So it's taking 3D pictures. So it'll take a picture from one side and a picture from the other, and the computer assembles that to make a 3D model, and then the arm will go in and get it. And as I said, they're quite adaptable, and the new stuff, it's impressive. And they've taken huge leaps in the past 6 to 8 months. So if you saw this before, as little as a year ago, it's almost in another generation. There's also some strange and somewhat esoteric uses, like there's a moving conveyor on the left. This was at a show I was at right before we all got shut down at the very beginning of March. And you struggle to find the application here. It's just kind of like, you know, it moves back and forth, and then the rollers will move a pallet. On the other side, on that right-hand side, there's a lot of work going on for depalletizing. And this is for large distribution centers that are trying to take cases off pallets. They put it on their conveyance system, and it goes out into the stacks. And someday they will retrieve those cases and build mixed pallets to go out to grocery stores or Walmart and all that kind of stuff. So the depalletizers are just coming online now. Hard to get them at scale. If you wanted to order 100 of them, I think the manufacturers would gasp. If you wanted to order 2, you would have some hope. But these are also pretty wonky. So far, when we were playing with them about 6 months ago, we were still struggling to get them to work correctly all the time. So, but again, the cycles of this stuff is really fast, and expect that if you wanted to start looking at these in the fall, that's certainly possible. The way a lot of people were going into the thinking was, if you could get an autonomous forklift, that would be all you need, right? So, and the forklift idea was basically born out of conventional thinking, right? It's a perfect example of someone saying, well, I've got forklifts. If I don't want a person, I need an automated forklift. And as you can see before, that the startups kind of turned that on their head and said, well, we can make all those little robots a lot cheaper. The automated forklifts are proving quite a bit harder to automate completely. And there's 2 things that make it difficult. One is the vertical travel, and you can get that. The ones that are on the market now, and they're just getting to market, do put away. So you can go up to 30, 35 feet, 5 or 6 high pallet racks, and it'll manage that depending on the lift that you've got. They're very slow when they're up in the vertical side. The cameras and so forth just slow the speed down. So if you have a large warehouse with, say, 20 forklifts, you might need 30 of these things. And the next problem with these is that they're expensive. So they're 3 times the cost of a current forklift, which is also reducing your people's rush to replace their current manned forklifts. And then the other thing is, as you can see that one on the right, it's designed to have a human drive it if necessary. So most of these forklifts are coming from the traditional big vendors that you've all known. So Clark, Raymond, Crown, Toyota, and so forth. They all are making these things that are man capable, with the idea that people might not be ready for the fully automated version. Like you see that one on the right, that was one at a show. It does have lifting capabilities. It can go up about 12 feet, and that's about it. But it's fully manned. Obviously, a person there's no operator controls for a person. Lastly, on the forklift side, and all of these robots, is no one has a reliable robot to unload or load a truck. So you're still going to need, if you could automate everything in the four walls, you're still going to need something coming in and out of a truck. It's just too difficult at this point. So that's changing, but if you were to set up a fully automated warehouse right now, you'd still need manned forklifts to get things in and out of a truck. Now, with all these form factors, you say, well, how does this apply? Well, think of it in the following. So I've got a manned forklift who pulls a pallet off out of the truck. He drives out of the back of the van. He has a little deck-mounted square waiting for him. He plops the forklift on it, and that square goes off and knows where it's supposed to go, goes off into the racks. And there's another forklift driver who's circling and gets an alert on his forklift in the stacks, who meets the robot, forks the pallet off, puts it on its shelf. Then you use those other little robots for picking when someone comes down the aisle and they need one case or one each or whatever they're needing to pick to build their kits. They use those little robots, follow them along, and the person then stays and he's doing the human stuff of picking, which is still, notwithstanding those arms, still humans are better at it. But the robot takes away all that travel time to send your kit or your series of totes out to its next destination, the shipping dock or the manufacturing line or whatever it may be. In other words, you're going to have this heterogeneous group of robots that all look different. You won't just replace your forklifts with automation. And that's a big aha for a lot of people that have expressed like kind of surprise and it also is very cost effective. So we'll get to the costs in a little bit. All right, market financially is exploding. This is an updated virus slide, as you see. This just came out a couple weeks ago. And it's in the billions of dollars worldwide. So, and it's growing sharply. It's probably the only thing, if you wanted to buy stock, that you would be sure that something good is going to happen. But anyway, notwithstanding the depression from this year, it's scheduled to reaccelerate next year, assuming we're all in the clear, of course. But it's quite a robust market. Just one last thing. The market here is basically three regions, as you'd expect. So the North American market, the European market, and the Asian market are driving this. So, and all three are doing slightly different things. But generally what we saw from the form factors and so forth is a North American model and a North American approach. So I think the most interesting thing about this is the market itself is driven by mature startups. So all of those robots we saw, except for that forklift, come from mature startups that didn't exist anywhere from 3 to 8 years ago. So they're very, very new in terms of what they're doing. The other interesting thing is that of these, 6 of them are all located within about 5 miles of each other in Cambridge, Massachusetts. So they're all a bunch of MIT guys, tall men, who have taken their graduate school work and turned it into companies. The only ones that are not is Fetch is out in California, so it's a traditional Silicon Valley startup, and Gray Orange is, interestingly enough, headquartered in Singapore. So, but they have a huge operation here. They're all venture-backed, they're all very well funded, and they are all at producing robots at scale, depending on what you want. I've personally used Seagrid. My implementation that I've talked about earlier was with some Seagrid autonomous tugs. But I'm not going to recommend any of them, over the others. They're all they're all credible. On the other hand, when you try and integrate all these, you need some software to control these robots. And I'm going to keep coming back to this because this is the gap in the market. No one has software right now that can control a mix of 3 or 4 different vendors' robots. And if you come from a manufacturing side and you're used to manufacturing control systems or MES, you know, the typical names, you've got Honeywell and Siemens and so on. None of them are early in the game. Honeywell is very late to the game. Swisslog is it's a Swiss company that does warehouse automation. Knapp's an Austrian company that does automation. They've got some stuff, but they're still not playing nicely with these folks up above in the startup space. Bastion is a Toyota division. They seem to be the most vendor agnostic when it comes to the hardware. And this is, again, it's an emerging space. So 6 months ago, you couldn't have even put these on the list. And I would expect 6 months from now, you'll have 10 more credible integrators on this list who you could trust. But very, very fast moving space, and it's a huge gap. I'll come back to that as we talk a little bit about implementation. It's expensive stuff on the integration side. So these people, as we all know from automation projects, never come cheap. The robots themselves actually are pretty cheap, and they are not CapEx. Almost all of these startups are doing their robots either some sort of lease, or they call it robot as a service, so RaaS. And so one of those cheap deck-mounted ones is, just think a rule of thumb is $25,000 a year, all in, to have a deck-mounted robot in your facility. And you can think about if you can replace a person, you know, at $25K a year, these things are pretty easy to get to. It's pretty easy to get to an ROI that makes sense. Okay, the market also continues to consolidate, and even despite all of our own homeboundness, Seegrid raised another big round just in April. So people keep buying these, and the other one is that the one at the top, Shopify. If you don't know e-commerce space, they're a big e-commerce player, mostly in the on the system side, and they bought 6 Rivers. So it's a very interesting move on them as they try and position themselves deeper into the physical supply chain. And this will continue as all these business mergers and acquisitions do. Okay, some other types of robots that we haven't talked about. There's drones, and you can use those in warehouses. I'll talk about that a little bit later. Then people will call robots things, the old assembly, the welding arms, printed circuit board, pick and place machines, and so forth. All have similar technology. A little bit older generation, don't typically move around a warehouse. You also got, of course, smart conveyors with PLCs and lights to put things back and forth. And then there's some really early days of integrating 3D printing machines with other material handling. Very infantile in terms of its development, but space to watch, I think, especially given, as we've all seen, that the news of how 3D printing is coming to the forefront of quickly manufacturing prototypes and coming up with our PPE and so forth that we need throughout the country. All right, deployment. So the first thing about robots is to understand you have the real problem described, and you know what your goal is, and that you're not just experimenting. I mean, maybe you want to, but you should be obviously attacking a business problem. And I'll tell you the drone story. So this is 2016, and I was a relatively new CIO and a 3PL, and this small drone vendor came to us and said, the FAA has just restricted us from flying without line of sight for the drones. We think we could fly it in a warehouse. Can we try it in one of your warehouses, Kevin? And at that point, the safety protocols for a drone was if it sees an obstacle, it goes up. And that's really bad in a warehouse or any kind of facility. So we did go fly them, and then we discovered that the cameras were too heavy, the batteries didn't work right. We had to relabel stuff, all the things you would expect in drones. And this came to light very quickly. And so we're sitting around trying to figure it out. And one of my team members says, so we're trying to use drones to count inventory, right? And the table says, yeah. And he goes, why don't we get a golf cart, bolt a pole on it, put all these sensors and cameras on the pole, and we'll drive up and down the aisles, and I bet you it's cheaper and easier, and we can get it working faster. And he's right? So the idea is don't get enamored with the technology, try and solve the problem. In this case, we're trying to count inventory with cameras on drones. It's a funny story, but it also exemplifies that, you can quickly get enamored. And everybody in my company they were stoked. They're like, man, we're flying drones. We are so cool. Well, maybe we didn't actually implement drones very quickly because the engineering problems were quite difficult. So last one is, second one is just on your personal level, is if you are going to do this stuff, you're going to have to get online at night and do some studying and figure it out. There aren't any books you can buy. Unlike the great stuff we get from Apics, there's no courses you can take on robotics. This is all, you gotta be out there kind of scratching and finding your way through it to figure out the technology and how to apply it. There is a fair amount of material on the internet. There's emerging web blogs and so forth on this stuff. But there isn't the infrastructure to learn like we talked about as Apics members. All right, back to this, the technical needs. You can't have robots without some sort of execution system. So, and the problem is pretty easy. So you've got these robots that have all the safety protocols and general navigation in the vehicle. But imagine two robots come to a corner aisle, and then you have it'd be almost comedic, right? If they don't know. After you. No, I insist. After you. No, please go first. Oh no, I'm happy to wait, right? And unless you have the software that can control these, then you're going to have these bottlenecks. And that sounds really silly, except if you have a bunch of robots that are from different manufacturers, and all these manufacturers have wonderful software to control their fleet of robots, but not anyone else's. So you need this third-party layer of this execution system or control system. And again, if you're from the manufacturing side, you'd think this is, you're scratching your head going, you mean it doesn't exist? But it doesn't exist yet. It's just coming now. The next thing is that the sensors will generate a lot of data. And so your IT team needs to have some plan for what to do with all that. The vision of these vehicles, it collects a lot of data in terms of that might need to be processed outside of the warehouse or the manufacturing facility. So if you have a building with limited bandwidth, and this is very typical for a DC or warehouse, they're on the edges of large cities, they're plowed up farm fields, and the ability to get high-speed fiber is just not there. You may have to think about how you put your computing power into that building so it can process a lot of the video or the data that's being produced, condense it down, and then send it to the central servers for storage. As a CIO, that's a nightmare, right? The last thing you want are more servers out in these buildings, but it's just a fact of life. The other reason to have servers in these buildings is there is some networking effect and lag for safety at the network level to make them all stop or make them all go or something like that you'd want to have controlled as locally as possible. The other thing about doing this is that if you have a low-tech manufacturing facility or warehouse, you're probably going to want some sort of control center to handle all the screens that are going to be produced. And so think about your facilities issues. Where do you have these technicians sit so they can monitor these things as they're running around? Not a big deal, but you're going to need something. It can't just be somebody's PC in the corner. You got to think through this a bit more. All right, as I talked about, the execution system becomes a layer of technology. The next emerging layer of technology is vision, which is competing with LiDAR. And this is actual cameras taking 3D photos. The compute power to use visual sensors is much, much greater than with LiDAR. So it's coming on slowly, but it has some advantages in terms of it can, because of the 3D ability, it can make better decisions on what it needs to do. So you're seeing some of these guys mixing them right now. So you'll have some visual, some LiDAR sensors. You know, some people who are completely dedicated to building visual sensors and so on. Emerging space. So keep an eye on that. Again, as we talked about the manipulation and robots, grabbing and so forth, this is the stuff that's really under development and is accelerating in terms of how good those are getting. Talked a little bit about traffic management. If you get hundreds of robots in a facility, how are you going to manage those? And along with that, not just manage the robots, how are you going to manage the people? So one of the things that people are proposing is that the humans wear, with their safety vest or whatever, they wear some sort of sensor themselves, so you can tell where they are, you know, front and back or whatever, however you do the sensor. From an engineering standpoint, that's a superb idea, right? Now we have the people positioned, the robots know where they are, they're not actually definitely going to run into them. From a worker happiness standpoint, it's a terrible idea. The early tests of this stuff, people don't like them because they think you're tracking them, right? So they're saying you want to know, you'll know even when I'm in the bathroom. And as engineers, we don't, of course, want to know that at all, but the people are sensitive, so it's got some issues to resolve. The last one is the diagnostics on the vehicles. These are electric vehicles, so they're going to be producing different types of information than people are used to if they have vehicles with propane or something like that. And then the diagnostics, as we all know from an IoT, there's just tons and tons of sensors, and they're giving off all kinds of data. Which brings me to the next thing is that you've got all this data coming out of here, and your engineers, if you've got some industrial engineers and mechanical engineers, your data analysts, they're going to go crazy with this stuff. They love this stuff, right? Because it's coming all the time, and it's updated, and it's pretty simple data, so you can do lots of advanced modeling with it and so forth. But here's a question. So back to the business thing is, if you know where your robot is down to 1 centimeter, what is that worth to you? Versus if you know 1 meter. And it's not clear, but some of the early return on investment models were talking about, well, you know where everything is all the time. And it's not clear that that kind of detail at the centimeter level is worth anything. Now, the speculation and the data side is that the data analyst will figure out something to do with it, and they probably will. So it's kind of the field of dreams. If you build it, they will come. So if you have the data, someone will figure out what to do with it. But the last thing is, again, if you're talking to your IT people, make sure that they know what they're going to do with this data early on, because it can, you know, rack up some serious storage if you're not ready for it. Okay. People. So you got some new skills here because of this. You've got people who are going to need to be able to be sensors. That things get kicked, they get bonked, and you're going to have to be able to repair them and replace them. People who need to know batteries and electrical systems, that may not be a skill set that you have in-house. You can get, just like most of these warehouses and manufacturing equipment, you can get third-party service contracts, people on site, 4-hour help and all that kind of stuff. But still, it's a working set that you may or may not have. More interesting is you're going to get some interesting new teams. So now you're going to have IT developers, perhaps a mechanical engineer, and some maintenance guys working together. And the first thing you're going to get is, because it happened to us, is I put a couple of my IT people in the thing, and they said, so we're going to do an agile project, right? And the maintenance guy, you can imagine what he said. And the engineer said, well, I'm Six Sigma trained. Let's and so as a leader, you got to kind of think about how these people are getting thrown together and working through these problems. Not big, but early on, it'll make you laugh and wonder why your team isn't more productive than it should be. We're talking about pilots, if assuming we get back to work here. You want to keep your team small. This is obvious stuff, right? Pick just one area of a warehouse or a manufacturing facility. So delivering kits to the one part of the line, taking pallets from one set of docks out into a certain one area of the warehouse. You want about 2 to 5 vehicles. We prototyped with 6 when we tried it. But we actually built into the prototype. So we started with 2 and then put the other 4 in very quickly after that and then stopped so we could watch what was happening. I would only do with 1 vendor, right? Despite all those things that I talked about. Try and solve one simple problem. Last thing we talk about we always are talking about the thrill of the technology and so forth and how cool it is. We did have people come up when we were putting these things out on the floor and say, so that's a robot, huh? Am I going to lose my job? And, you know, the junior engineer on the project or the technician or something may or may not be the person to answer that. But I had all my guys trained. I said, you know, when you're out there, you've got to put a human face on this because we need those people, at least in the short term. At that point, we didn't even know if the thing would work, right? But they're going to be sensitive to it. And this isn't a question of they're going to go sabotage it or be mean about it, but the angst that they're going to feel is real. And I just caution everybody as leaders to be very, very careful about how you deliver these messages. Okay, on the ROI, it's pretty simple. It's mostly operating expense. So as I say, most of these are leases or services. All of those small startups are offering services. So it looks a lot like a software as a service. Sign up for 24 months or 36 months. It's 25 grand a vehicle, a little bit of startup cost, and you know, knock yourself out, right? So one of the things you have to think about is, as we all do budgets, is this, can we, you know, slide it into the CapEx somehow? And those are accounting questions that you may or may not be able to handle. We do see that the emerging literature is that the budgets for these in the early on come from all over, right? So the engineering groups, development teams, R&D teams might want to fund the first pilots. IT wants a bit of it sometimes because they've got a lot of software to do. And then of course operations. My experience personally with different clients is that try and get budgets from everybody, right? It just makes sense when you try and pool it all. The major savings is on cutting labor hours. So just like we talked about that poor guy who's going to lose his job. The savings is cutting the travel time from going from A to B. You know, a person sitting on a forklift traveling across the building is adding no value at that point, right? So if you can get the robot to take away that stuff, that's your ROI. In a very large warehouse or distribution center, you're going to see horizontal travel be up to 2/3 of your labor cost. So you can very quickly get to an ROI in a large several 100,000 square foot facility. Depending on the density in a manufacturing facility, you might be able to get a similar number. Smaller warehouses, you know, something under 100,000 square feet, you might be hard pressed to get a good ROI given the costs that we're seeing. But anything greater than a couple 100,000 square feet, it's almost a sure thing that you'll get an ROI. Okay. I have been talking fast. You know, when I first built this slide, I did this deck, a modified version a few months ago, and it's a lot easier to do it when you can look at people and see what they're doing. So I'm going to throw it open to questions and answers. Got a bunch of chats. Beg your pardon, I'm going to open the chats here.
Yeah, I'm going to just, while we're doing this, I'm going to unmute everybody's phones and allow anybody to ask any questions. Your phones have been unmuted.
Well, I have one to start off with, Joe Grigg. Did you see any kind of some of the older models of automated systems in the 70s and 80s, pick-to-lights, were very sensitive to humidity in the warehouse? How much issue of uptime did you have to face?
These early models are fairly robust. They have a maintenance schedule. And one of the big issues was, and they have a charging time, right? So you have to go send them off to battery charging and so on. The one thing that we didn't understand was that the sensors get knocked out of calibration all the time. So the technicians were constantly tweaking with the sensors. Now, it's not a big repair, but we were surprised at how much we had to pay attention to that.
Okay. We have a question from Jerry. How small of a warehouse is this type of automation effective today? Small, large? What do you got?
Most of the stuff is going to be for a bigger warehouse, so a couple 100,000 square feet and up. The travel time in a smaller warehouse. So I have a customer with a 30,000 square foot warehouse, and it makes no sense. The amount of time for a person to step from one side to the other is not enough to generate ROI for putting in the hassle of putting in a robot. So I would.
Kevin, with how are these robots mostly controlling where they at? Are they using targets or locators that are scattered around the warehouse or in the floor or on the walls, or are they using a GPS system?
We lost him. That cut him off somehow.
Bad question.
It said on my screen that he left the meeting.
Oh, no. Hopefully he comes back on in a minute.
That will be my bad. I will own that one. Sorry about that.
Uh-oh.
Let me get
There he
Kevin
is.
back on real quick.
Well, we got his picture. There he is. He's back.
Got kicked out.
There you
So
go.
I'm sorry, was there another question? We're talking about
Yeah, we
size.
got
That
a
Kevin,
couple of ones.
Yep. Kevin, this is Roger. I was just wondering, how are these robots mostly using targets for locators in the floor or on the walls in the warehouse, or are they using a GPS locator system?
They're using an internal CAD map that you download and then learning from that. The interesting thing is a lot of these robots will actually remember, like if you put a pallet at the end of an aisle, right, while you're taking it off the line or whatever, it will remember that that pallet was there before and start to track out into the middle of an aisle as it comes closer. So you don't have to set up wires in the floor. Sometimes you need a little bit of reflectors for tertiary navigation, but that's it. It's really lightweight in terms of what it needs in the facility.
Got another question here. If the warehouse currently has no conveying, would it be better to try robots first that the tech is getting mature?
I think it would depend on what your warehouse is doing, right? If you're just moving pallets, robots might be really nice. If you're doing each picking, robots would be really nice. If you're doing case picking, then conveyors might actually be the solution in the middle.
Right.
So,
Okay, one other
depends on
question
what you
here.
got.
In what types of manufacturing industries have you seen this technology implemented successfully?
Personally, I've seen it done in food. So mostly at the end of the warehouse where people are, end of the manufacturing line where they're trying to get into finished goods. I did visit a manufacturer here in Colorado that was making carts for kitting. So you would build, your standard job kits, put it on the cart, and then it would go off to whatever line it needed to be at. They got bought by Amazon, so they're off the market for all the rest of us.
Canvas technology.
Canvas, it was Canvas, right?
I built circuit boards for them.
Is there anybody else out there that has a question? Shane, do you have a question?
Yeah, I do. Thanks. Kevin, thanks for walking through it. I thought you did a really nice job summarizing it. I was curious why this is a space for startups and not some of the more traditional companies in robotics like Fanuc or Kukai or somebody like that. What's sort of your thoughts on that?
I find it the most interesting thing. I think my familiarity with the forklift manufacturers is probably the better anecdotal story. Is those guys are just too slow, right? They were thinking in terms of 5-year plans, and these startups came along and said, well, we can build something in 18 months, and and guess who gets the business? So the more traditional robot space, there's people out there doing stuff with drones, with the arm, articulating arms and so forth. That's a ginormous space of startups and established. So these movable guys are just it's a really odd. It's not a usual case study that you would ever expect.
So we've got a couple questions about error percentages of these systems. What are the major errors that the robots commit, or what kind of percent? What's the percent like?
The biggest error is that they'll shut down for a security thing that they didn't have to. So there's a false positive, and that's okay, right? When we were putting in the first generation, that was our biggest thing, that they would shut down inexplicably. The other one is we're still working out the protocols. Is these things move slow. They're not as fast as a typical forklift or a human. They move usually just about the speed of someone walking. And if they sense something is going on, like they sense that they're too heavy, they'll go even slower. And we didn't understand that when we were first starting. It was super hard to figure out, why is it going half speed? So those were the errors that were coming mostly from startups, our startup address. But the inexplicable stops were the most common problem.
Okay. Anybody else got any more questions? Mark, I see Mark Stacy. Did you want to ask a question?
No, I'm good.
Okay.
Just one last question for me, Kevin. Do you kind of think that this, with the situation with COVID-19, that it may change the business case for many companies as sort of a risk management and being able to continue to use some of this stuff?
I think the use case will accelerate. So if you can tell, you got the standard ROI for getting a human out, and then the risk of being able to run your facility with less people, or the risk mitigation because you can use less people, tons of push for that. So if you're, like I say, if these guys are public, I'd be buying stock in those startups, because I don't see anything but up for them. And even before this, right, it was really hard to get forklift drivers, right? A big warehouse operation will see turnover of 30% or greater, and that's not unusual, maybe up to 100%, just because they can walk across the street and get more money, right? So if you can automate your way through the lack of, if we get back to full employment, and I hope we do, these robots will still make sense because of the pressure we were under just in 2019.
There's a question about speed with the AI learning more and more and things going faster. But in a warehouse, I imagine that you wouldn't have the robots going very fast just for safety's sake.
Right. It also depends on what they're carrying, right? So if you're, imagine one of those deck loaded moving a pallet, right? If it's a really high pallet that's it's a little wobbly, you want it to go slow. So this is the big push right now for the development groups, is to get them to be able to speed up, because it also helps the ROI, right? If you've got, again, 10 forklifts now, and you want to automate, you're going to need at least 1.5, maybe 2x vehicles to replace all those, just because they're slower.
Okay. James Grieger, did you have a question?
Yeah, I did, and I'm particularly interested in the information handoff. When you use the example of, okay, you have a human forklift driver pulling a pallet out of the van, the trailer, and you hand that pallet off to the robot. Now, how does the robot at that point get the information to know which aisle to place that for eventual put away? Is it scanning the barcode of the pallet, the license plate, or is there a some kind of a signal from the forklift driver? How does that work?
Yeah, the signal from the forklift driver. So this is assuming that the lift operator's got a tablet on his lift, and he's going to be dialing in through his warehouse management system or SAP or whatever you're using to say, I've got this item, I've scanned the barcode coming out of the van, and his tablet on the lift is going to say, put it on little robot number 2, and then when he hits commit, it's on the robot, then the robot goes and does its thing.
Okay.
All right, let's take one more question and we'll wrap this up.
Joe, this is Brian. I was going to ask Kevin if he has a minute.
Yeah.
So Kevin, one of the things I've been involved with robotics in the warehouse for a couple of years now, but one of the things that to me is not only kind of hard to do, but I wondered what you've seen right now to address with the group is the shelf picking. So there's pick assisted, there's goods to person kind of robots, but what have you seen with you kind of highlighted it a little bit there, a robot that could actually pick an item off a shelf without a human being part of that. Are you seeing a lot of that, or is that way out there?
Yeah, the technology's here, and you can buy it at scale. But the deployments are very few. At the automation show I was at 6 weeks ago, the use cases, the actual use cases were really small. But everyone is telling me, if you want to order, we've got production units. The thing with those picking robots is you probably have to rethink your picking line, right? So that picture of the picking that's more like a retail operation, right? So maybe someone doing retail fulfillment or something like that. That may be very nice, but the stuff at scale is going to be a bigger operation where you're picking for kitting for manufacturing, or you're picking for an e-commerce facility.
Right. Yeah. And you have so many issues with size, weight, shape, all that good stuff, right?
Right. And then, yeah, those arms they have specific parameters, right? So they can only pick up to 10 pounds, and the size of a shoebox and all those types of things.
Right.
And so your flexibility with them to process all kinds of different things, especially if you're in an e-com environment, is still limited, right? So you've got to very carefully route that kind of good to that picking arm that can do the size and types of stuff you need.
Would they be up in the mezzanine or pick module?
Could be, right? Yeah, you'd have a mezzanine where you're doing a lot of each picking. It'd be a very logical place to put it.
Okay.
Joe, one more question. It's out here from Bill Sullivan, and I had the same question. Kevin, are these robot companies, are they creating their own WMS systems, or are they making their robots interoperable with existing data collection systems, advanced warehousing systems, warehouse management systems in general? So
here's where the startups are doing well. They've all expressed that they have open standards and public APIs to integrate. None of them are making their own WMS, so that space is still locked up with the Manhattans and JDAs and SAPs of the world. They do have that controlling layer for traffic management and so forth. But what's emerged is that if you're a robot manufacturer, selling that control layer for all the robots is quite problematic, because your software won't necessarily talk to the other guy's robots easily, or there's some sort of legal threshold. We got into all that. So the best thing for that traffic, that controlling layer, is to get it from a third party. So this is where Honeywell and all those guys made their money in manufacturing, right? And you would think that they'll be there, but it's wide open right now in terms of who's got a usable solution.
Thank you.
Well, thank you, Kevin. I can't tell you, this has been a fun time for me to sit there and do this. It's been I've enjoyed it quite a bit. Normally I'd be walking up to you right now with a bottle of wine. I guess I'll have to get you at a different time.
Yeah, fair enough.
I guess I want to say a big thanks. We normally hear a big round of applause. Everything to Kevin.
Thank you.
All right. Okay, so our next meeting will be another webinar. We're going to do it on May 13th, a webinar type event, and I've got the former president of Apics talking, Alan Dunn, and he's got quite a visionary on how to handle this current COVID-19 stuff. The topic is going to be planning 2020 demands through COVID-19 simulations, triple bullwhip. So it's going to be a great meeting. On May 13th at 7 o'clock, we'll run the same kind of situation. I'll send out a bunch of registration invites, and then towards the end, I'll put the link up there and start sending out reminders to the link. So before we wrap up, we do have a capability to send to do the $100 drawing. It is just $100 because Ken Cruz won last month. So here we go. Let's do the drawing. All right, can everybody see it?
We got you, Joe.
Here we go. Daryl Spur. I don't think Daryl's on. He's frequently a member too, or frequently here. That's too bad, Daryl. All right.
You know, Joey just told me the other day he was going to attend too.
Ouch.
He's very sad.
All right, folks, drive safe. There's going to be snow tomorrow. Stay dry, wash your hands, and hope to see you again in May.